Good afternoon. Is the screen visible?
Yes, sir. Yes, sir.
Okay, done.
Yes, sir.
Yes. So we were discussing about the module 4, macro processor, and we have moved up to the data structures and algorithm. During that process, we touched upon the 3 data structures that are required for the macro processor to be implemented in a 2-pass. To reflect on those 3 data structures, we have these data structures, namely def tab, definition table, name tab, name table, arg tab, argument table. As the name says, def tab contains the definition, meaning that the body of the entire macro will be stored, and the name tab will have a data structure similar to a symbol table, where it will have the name of the macro with 2 pointers, one pointer pointing to the beginning of the body of the macro, which is part of your definition table, and the other pointer for the pointing to the end of the macro definition. Then we have an argument table, which is going to house the actual parameters or the actual arguments that have been used in the invocation or a call for a macro. This is how we have discussed. We have also looked at the possibilities of changing or modifying the argument table in order to act on the nested macros. A nested macro meaning that a macro defined within another macro, pretty same as the recursion process, where one macro is getting executed, another macro will be called. During that time, there are possibility that the initial macro or the top level macro parameters getting replaced by the next level or subsequent macro invocations, which is not right. Hence, the solution for such type of challenges could be in terms of the stack being used as a data structure to implement a nested macro, so that in the last in first out fashion, we will not be able to lose the parameters of the first call or second call or the subsequent call until that particular macro call is executed completely. In other words, nested macros can be easily handled using stack as a basic data structure, such that all the macros in the nested macro concept will be easily or rather comfortably executed or expanded without any challenge. And second, we observed is in the definition table, instead of writing the ampersand type of business, we'll be using the positional parameters, meaning that if I have 3 formal parameters, instead of writing them ampersand 1, ampersand 2, ampersand 3, we will be replacing that with a question mark, 1 for the first parameter, 2 for the second parameter, and 3 for the third parameter. That's what we have seen with respect to the data structures. And coming to the process, that is algorithm, as we discussed, there are 3 to 4 sub modules, sub programs. Your macro processor algorithm has been devised or identified. In the 2 we have seen probably the get line, process line, and the beginning of the macro processor. We have seen these 2 macro processor algorithm concepts. We'll go to the further. In this, get line is not discussed, expand is not discussed, define is not discussed. So we'll see how these 3 will be identified. So we have just seen how the beginning of the macro processor algorithm, that is our main program. Later we have seen the processing line, where each name will be considered. They will identify whether it is the definition of a macro or it is a call for a macro. If it is a definition, it will be going to the definition table or the define process. If it is a call for a macro, expansion will happen for the macro wherever there is a call. So both of these we have to see now. One is the get line, expand and define, which are part of the process line. Let us look each of them separately. Now, so define process. Now, we are in the main program. From the main program, we have moved to get line or process line. Assume we are in process line now. When you go to process line, we have two things. One is a expand, other one is a define. Now we are at the define now. So when you come to define, what is going to happen? The macro definition has occurred. That's the reason why we have come to definition. Okay. Next. So we enter the macro name. Since we are defining the macro, definition table will be considered, as well as the name table will be considered, and these two tables will be used as the data structures under this process. So we enter the name of the macro into the name table because we are at the definition now, and we also enter the prototype of the definition table. That means what is the M macro type of line and M end line, because these are the two pointers which are pointed by the name tab, because we have two pointers there. So name tab will be filled with the name of the macro. Definition table will be filled with the first two lines, that is the first line of the macro and the last line, that is a macro and M end, so that the two pointers will be pointing to, which is nothing but a prototype of the macro definition. Then we initialize with the level 1 because we don't know whether the macro is defined in another macro, meaning that nested macros have been given. So we assume there is only one macro, there is no nested macro, but if nested macros are there, we can engage them. We already discussed that level is the one which is going to be incremented as and when new or macro level is used or a nested macro is used. And once the execution or expansion is over, the level value will be decremented. So thereby, at any point of time, level value will be always greater than 0. So if we start with 1, maybe 2 or 3, or maybe same as 1 only. At any point of time, it will be always greater than 0. Once it becomes less than 0, meaning that you have successfully completed the process. So we verify that as long as value is greater than 0, we'll begin. Again, get line. So we'll see what is get line soon. As name says get line, it is going to simply get the line. Let us have a look at that. So get line is, if you look at here, it is just taking a values. It's a very simple one, but assume at this point of time, get line is only taking the line of the program. So we have taken that line. If it is not a comment, as usual, if it is not a comment, we'll go into the processing. So substitute the positional notation for parameters. We are in the define. Let us not forget that. When you are in define, the major work is going to be with respect to the definition table. So each line of the macro definition will be copied into the definition table. So we enter that into the definition table along with the actual values that we have given for the what you call formal parameters. But instead of writing the name of the parameter, we just write the positional parameter like a question mark 1, 2, 3 and stuff like that. Okay. Next. If it is a opcode is a macro, that means if there is another macro defined within the macro, we already come here because opcode is a macro, but there is another possibility that it itself might have another macro being defined. If that is the case, if we find a nested macro, then we have to increment the level. So level 1 becomes level 2, meaning that one more macro has been defined in a currently existing macro. Then else, how long we will be doing now? Until you reach the M end. If you encounter M end, then we have to decrement the level. So every time when macro definition is encountered, level will be incremented. Every time a corresponding M end is encountered, meaning that that particular macro definition is completed. So we have to decrement the level. So for whenever there is a macro, we increment level. Whenever there is M end, we decrement the macro. So we have processed now. Until this, we are going to copy everything that is part of a macro definition along with the values what we have. Next, store in the name table pointers of the beginning and end, because every time when you store the definition table, we should have the corresponding value to be updated in the name table. They are nothing but the beginning of the pointer for the macro body and ending of the pointer for the macro body end. If that is the case, we need to provide these two at the end of the every macro definition. So that's what we have. So this continues until we have all the macro definitions are captured into the program, into the system. So this is the definition. Next we have a processing. So let us see how processing will be done in the expansion now. So we have seen define. Now let us see expanding. So until this, so in the beginning we have assumed that expanding is false because we don't want unnecessarily expansion to be true. Only when expansion is required, then only we'll go to the expansion is going to be true. So when expansion is required, when you have a expand here, when that is possible, when we have a opcode, when you have a opcode which is a name of the macro. When opcode is the name of the macro, it is nothing but there is a call for the macro. When there is a call for the macro, then we need to expand. At this time, we are coming to the expand. So when you are coming here means then expanding has to be made true. Until then, expansion will be false because we will be expanding only when there is a macro call, not always. If that is the case, we will be making it true. Once you make it true, then what follows? Wherever there is a call for the macro, that call will be replaced by the body of the macro. How do you get the body of the macro? Body of the macro is available from the definition table. In the definition table, there will be multiple bodies. How do you know this is the body of your macro? Then that is given from the name table with the 2 pointers. So using the name tab, using the definition table, we are going to expand the given macro call, and corresponding to that, the instructions will come and sit in this system. Since next, when there is expand, the another data structure what we have to use is an argument table, because every macro call will contain actual parameters, and those parameters need to be stored in the argument table. So argument table will store these parameters again with the number 1, 2, 3 positional parameters. Okay, because we have used the positional parameters in the definition table. Corresponding to that, numbers will be used in the argument table so that the one-to-one mapping will be done for these positional parameters. Next, once that is done, then we will be expanding the given macro call, and that macro call will be expanded verbatim as required, and that will be written into a separate file. So once that is done, then we'll go to the next line, next process line. So this continues until you get the other, what you call other line. So the other line while processing, again it might be a get line or it might be a process line, because there might be a call within another macro, or there may be another macro call within the same program. So we'll see both. When that is over, then probably we have to close the expanding, because expanding is made false initially. We have made true only for this purpose. Now, since it is true, once the expansion is over, then we have to make it false. Like flag 0, flag 1 we use in the program, we are going to make expanding false. That means for future, expansion should not be done unnecessarily. So this is only for the expand point of view. So expansion is over now. So once expansion is over, we have done definition, expansion is over. Only thing is now we need to understand how get line is done. Otherwise, the algorithm is complete with this. So we have a get line, we have a process line, we have a define, we have an expand. These are the 4. In addition to that, one main program is what we have. So let us see what is there in the get line. So get line is for 2 things. One, if it is expanding is there, how to use. If there is no expanding, how to do now. Okay. So if there is expansion, then probably we have to take every line from the definition table, copy that into the wherever we have, and substitute those arguments from the argument table for the positional values. What is written as a comment here is what being done by the get line here. If it is expanding is true. If expanding is not true, then simply we read the each line, copy as it is. When there is no expansion, meaning that when there is no call for a macro, then it is simple to end like any other program, we copy one-to-one. Whatever instruction we have, they will be copied as it is. That is the concept behind the get line. If you look at the type of algorithm we have, the algorithm is like this. The first one is the major one, or the main one rather. So in this, we have made expansion as false, because expansion happens only when there is a call. So until then, it is a false. Then we'll see until we reach the end of the program, we go to the get line or process line. So what is get line here now? So get line means either it is expanding or normal. First we'll go to the else part, because normal lines will be copied. Okay. So next we have a process line. So if it is a process line, again there are 2 things. It can be expand or it is a define. First let us go to define, because normally definition has to happen. So this is a define. So definition means we are going to update the definition table and the name table. Once definition is done, then it may be possible to have a expand. So what is there in the expand now? In the expand, we again go to the body of that particular line, or we process this again, because a macro might contain another macro. That is the reason why this is a repetitive or a recursion here. So by making expansion true, we follow the same process. Once the expansion is over, we have to make it is a false. Otherwise, it will be always in the expansion mode and algorithm may go erroneous. So once that is done, I think we are done with the get line, we are done with the process line. This will continue until we reach the end of the program. So this constitutes the major part of the algorithm as far as the macro processor is concerned. Here, as we know, it is a two-pass macro processor, meaning that in the define process, we are going to store the values of name table and definition table. In the expansion table or expansion process, we are going to update the argument table and make sure that your expansion takes place with the real-time data. That is the idea behind the algorithm what we have for the macro processor. It is divided into 5 parts. One for the main, second for the process, which contains either expansion or define, then define and expand separately, then get line. Get line is like read statement or a scanf for you, just how we are going to read. Since we have a definition table for the definition stage and expansion table for the expansion stage, we have written if else condition, how that get line has to be used or processed. Otherwise, it is simply reading the data from one to one. So how do you read? You may read directly from the main program, or during expansion stage, you may take the value from the definitions table. So make sure that whether you are using definition table or a direct main source of the program, to differentiate that we have a get line. Otherwise, get line is a simple one statement which is going to get the data. Otherwise, so the actual program contains define, expand. Those two are embedded into processing. So like this, the program or algorithm has been designed so that we can understand easily. So go through it once again quickly. If you have any doubts, please let me know. It's very simple compared to your other algorithms because it is divided into pieces. You can easily understand and easily remember as well. So go through this once again. Wherever you have doubts, please let me know. Meanwhile, let me complete the attendance part. Asta? Abhinav?
Present, sir.
Aishwarya? Ambrish?
Yes, sir.
Anu?
Present, sir.
Arvaz? Arjun?
Present, sir.
Ashok?
Present, sir.
Benita? Bhargavi?
Present, sir.
Bhavisha?
Present, sir.
Chaitra?
Present, sir.
Chatterjee?
Present, sir.
Diksha? Deepika LG?
Present, sir.
Deepika MB?
Present, sir.
Murli Krishna?
Present, sir.
Gangubai?
Present, sir.
Guriya Kumari? Harshit?
Present, sir.
Junjar Singh? Kavya?
Present, sir.
Kishore?
Present, sir.
Lata?
Yes, sir.
Manisha? Manjunath?
Present, sir.
Nayana?
Present, sir.
Nilanjan?
Yes, sir.
Nishant? Pavitra?
Present, sir.
Maithili?
Present, sir.
Priyanka?
Present, sir.
Pavan Kumar?
Present, sir.
Akash?
Present, sir.
Rajeshwari?
Present, sir.
Rakesh? Ramya?
Present, sir.
Rashmi? Ravi Shankar?
Yes, sir.
Rizwan?
Present,
Sir,
sir.
present, sir. Rashmi.
Okay.
Rizwan
Vishal?
present, sir.
Present, sir.
Yes. Okay. Savita?
Yes, sir.
Shruti?
Present, sir.
Sneha?
Yes, sir.
Spurti?
Present, sir.
Srinidhi?
Present, sir.
Srinivas?
Present, sir.
Sunil?
Present, sir.
Vaishnavi?
Present, sir.
Vinny?
Present, sir.
Okay.
Arbaz is present, sir.
How are your boss? Attending classes regularly or not?
Not, sir. Sir, network issue, sir.
Uh, are you able to follow?
Yes, sir.
Sir,
Sir,
Aishwarya
Rashmi
present,
present,
sir.
Rashmi present given. Aishwarya
Aishwarya
given.
present, sir.
Puriya, okay.
Benita present, sir.
Manisha?
Aishwarya, sir.
Benita, okay. Aishwarya Aitama? Aishwarya done. So any doubt? Yeah. Come again?
Manjunath, sir. Present.
Manjunath Aitapa.
Manisha.
Manisha. Yes. Done. Any doubts in the algorithm? No doubts? Okay. Fine. Yes. So that is about the algorithm and data structures. Now let us get into the mission independent macroprocessor features. Okay. So there are 3-4 types of features what we will be looking at mission independent features of macroprocessor. So they are concatenation of macro parameters, then generation of unique labels, then conditional macro expansion, then keyword macro parameters. These are the 4 varieties what we'll see, and each one is very important and you will see some value behind each of them. From exam point of view, you will be getting at least a couple of them to be written in the exam. So one may be concatenation of macro parameters, generation of unique labels, or conditional macro expansion, or keyword macro parameters. All these 4 are a candidate rather for the exam point of view, and even you as a concept you should be able to understand. Let us look at the first one, the concatenation of parameters. So what do you mean by concatenation? How do you define concatenation? Any idea? What is concatenation? How do you look at concatenation? What do you get the minute somebody talks about concatenation?
Combining two
Combining.
letters or two
Okay.
words.
Okay. Yes. Normally we talk about this in terms of strings, right? 2 strings concatenation. That means one string attached with another string. For example, we have a student MCA. There are 2 separate strings. When I concatenate, what will happen? So first string is student, second string is MCA. It will become student MCA. If the first string is the second one and second string is the first one, it will become MCA student. So depending upon how the resource is used, accordingly concatenation will just merge. It is like a linking a one coach from another coach in a train or a metro, so that one after the other they will join together. So appending one after the other is what we normally call it as a concatenation. So here the similar to that concept we are using, but the idea is, let us discuss what is the context with which concatenation of parameters is used here. So concept of concatenations remains same. That is, two characters or two strings are merged together to serve some purpose. But the idea with which this concatenation of parameters is required or is used is what will let us understand now initially. Assume that we have an array. Normally we use array, no? Even in the beginning of the program, when beginning of the class of SS, we have used some programs in SIC, SICXE. We have used some array to store the characters, or array to have the numbers so that we can perform addition operation and stuff like that. So when you have taken that, you have taken say array like A, array like B, array like alpha, array like beta, so like that. So when I take array like alpha, so the values in that alpha array will be accessed like alpha 0, alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. But my requirement is that whenever I call a macro with a specific name, let us say I have defined a macro with alpha, but when I call, I will provide the actual parameter as a beta. So when I do that, so my macro should take the name as a beta 1, beta 2, beta 3 instead of alpha 0, alpha 1, alpha 2. If that is the case, probably I can look at the concept of a concatenation of a macro parameters. So here, to understand further, so let us consider we have a series of variables with names xa1, xa2, xa3 for 1, another series with xb1, xb2, xb3 and stuff like that. So when I am performing this in the program, I would have used xa1, xa2, xa3. But my question is now, when I call a macro in real time, I want to replace this as a alpha a1, alpha a2, alpha a3, beta b1, beta b2, beta b3. How do I do that? If that is my requirement, then how should I go about it? Then we can do that by using the concatenation of macro parameters. Okay, the parameter to such type of macro instruction should be specified in the form of a operation. That operation is going to be like this: ampersand id. That id, for example, that id is having say alpha, then I will have a alpha 1, alpha 2, alpha 3. If it is a beta, I will have a beta 1, beta 2, beta 3, like that. Let us take a real-time example as far as the your assembler is concerned, I mean your SIC is concerned, then you will understand how it is being done now. Okay, so we have defined a small macro here. While defining this macro, we have used ampersand id. This we know. While defining a macro, we write ampersand a, ampersand b, ampersand c, because they represent the formal parameters. So this is the definition. This is the body. So in the body, normally we would like to use LDA, ADD, ADD, STA with alpha 1, alpha 2, alpha 3, alpha 4. In our high-level language, if you declared array A, I could have used A0, A1, A2, A3. So irrespective of what value you process, what value you send, it will be always A0, A1, A2, A3, because we never wanted any extra name for that. We wanted only value to be used. But here the requirement is not only value, but also the name. I don't want the name to be same. I want to customize the name. Every time my expansion takes place. If that is the case, what I will be doing now, I will be using this concept. What is this concept now? Whatever the value I want to use, I can use it here. This will be prefix or suffix. And whatever the name I want to replace, what is the name I want to replace? Ampersand ID, ampersand ID, ampersand ID, ampersand ID. This ampersand ID will be replaced with the values what we have. So let us look at the solution now. Now, I am calling sum A. So what was the value here? It is a sum ampersand ID. I am calling with a sum A. So A is nothing but a ampersand ID. How I have defined now? X ampersand ID arrow 1. X ampersand ID arrow 2. So what I am expecting now? Wherever ampersand ID is there, that will be replaced by A, including arrow. So this becomes XA1, XA2, XA3, XAS. Let us see what is that we have got. So we have got XA1, XA2, XA3, XAS. When is this happening? This happens whenever there is a macro expansion. So you are invoking a macro like this. When it gets expanded, it is not X ampersand ID or something. I'm customizing this to my actual macro word what I have. Similarly, if I take another value or another invocation of a program like some beta, what will happen now? You will get beta A1, beta A2, beta A3, sorry, X beta 1, X beta 2, X beta 3, X beta S. Let us see. See, X beta 1, X beta 2, X beta 3, X beta S. Meaning that the middle value, what I have used, that is ampersand ID, will take the name of the actual parameter and remaining will be same. This is prefix and suffix. They are concatenated as usual. So this concatenation is happening at the beginning and the end of the value, and hence we call it as a concatenation of macro parameters. This is a macro parameter. Beta is a macro parameter. It gets concatenated with some prefix and with some suffix depending upon what we want. So suffix and prefix is only our information. If you want, you can use any of them. If you don't want, we can avoid them. So, but if at all you want to have this value, the method is ampersand, whatever the value we have, followed by arrow mark. That is going to be replaced by the actual parameter what we have. And this concept is nothing but a concatenation of macro parameters. When do you require that? Whenever you want to customize your macro call with the actual value that is being sent in the macro invocation, then probably we can use this macro invocation, macro concatenation. So macro concatenation can be happening or can be happened using this concept. This is a independent feature. It has nothing to do with the system. It is just replacing. It has nothing to do with the architecture of the system. That's why we are discussing it under macro processor mission independent feature. So one of them is nothing but concatenation of macro parameters. This is like a beautification. Prefix something, suffix something we are going to have here with this. This is what the idea, what we have with respect to macro parameters. That means concatenation of macro parameters. So any doubts on this? Probably we can take one more today and we can wind up out of 4. So before that, if you have any doubts, let us know. Concatenation of macro parameters. The concept is how to customize the given parameters with the macro actual parameters. Okay. If you don't have any doubts, let me move to the next concept, that is generation of unique labels or symbols. Generation of unique labels or symbols. See, the discussion of unique labels drives us back to the nested macros. So we have just now seen nested macros are part of the program. Second, we have a macro, and the same macro can be called more than once. And these two are very important concepts for us, because when a macro, if it contains a label, when it is repeated more than once, we know that the body also will be repeated more than one place. When body is getting repeated more than one place, what about our labels? Because labels will be common. If I have a loop as a label, when I copy the same program more than once, the same loop will appear there. But that comes as a ambiguity for the system, simply because system will not have any clarity when I use a concept like this, jump on less than to loop. Which loop to go? Whether it is a loop here or loop somewhere here, because I am going to call this macro more than once. When I call this macro more than once, the body will be repeated at more than one place. When the same body is repeated another place, so I will have another loop, another label by name loop. When I use this statement, the statement here will have ambiguity whether to go here or whether to go here. If it is called more than twice, whether to go there else. So total ambiguity comes for the system. You agree now? What is the concept of these unique labels? If a macro contains a label and that macro is called more than once, then there will be ambiguity for the system while processing that particular label, because the same label will appear at more than one place depending upon the number of times the particular macro is invoked. Assume now this macro is invoked twice now. When it is invoked twice, we will get a label loop at this place, say line number 10, and another place, say line number 50, because it is just an expansion. So when you are here now executing at line number 40, the system will have ambiguity when you say loop, because loop appears at two places. Here also it is there, here also it is there. Whether to use line number 50 loop or to line number 10 loop, that ambiguity comes simply because the same macro is expanded at two different places with the same label name. So to avoid this, what we have to do, for every macro invocation, we should replace the label with the unique label. That is the concept of a generation of a unique label. How do we do that now? To avoid this ambiguity, we slightly change the program. So how do we change the program? We say, let us take the program now. So this is the program what you have just now seen. So far we had only loop now. Now we have added a dollar symbol. So adding a dollar symbol will inform the macro processor that, look, this is a label. When this is called, every time you should create a unique label or you should generate a unique label. How to generate unique labels? Unique labels are generated using your alphanumeric characters. What are alphanumeric characters? 0 to 9, A to Z. So we have how many characters are there here? 0 to 9, 10, A to Z, 26. Total 36 characters are there. If you look at the combinations, 36 into 36 will have a 1296 combinations we have for this, which starts from AA, AB, AC, like you see in Excel sheet, no? A, B, C, D, up to Z, after Z, AA, AB, AC, after AZ, BA, BB, BC, after that, CA, CB, CZ, like that. We have so many options available with these characters. That means a macro, if it is containing a label, it can be called how many times? 1296 times I can call. It is very rare we call more than once or twice. So now we have option up to 1296. So absolutely you will not have any ambiguity here now, because you can call any number of times within that range, 1000 times. We have never come across a macro being called more than 1, twice or 10 times. 1000 times who is going to call? But still we have an opportunity to have these many number of invocations for a macro, and hence it is very safe to have a macro with a label still without any ambiguity. How is that being done now? That is circumvented by prefixing a dollar symbol to the name of the label, so that whenever there is an invocation for this, let us take this example. Now it is an invocation for this. What is happening now? It is a dollar loop. It is replaced by dollar AA loop. Suppose if I call it once again, what will happen? It will be called as a dollar AB loop, because every call in the same program will have a unique label generated. So every time you can have a different name, dollar AA loop, next time dollar AB loop, next time dollar AC loop, up to dollar AZ loop. Once AZ is over, again dollar A0 loop, A1, A2, A3, A9, like that. With A we have a 36. Like that we have 36. So 36 into 36, 1296 possibilities we have, so that a macro can be called more than once or twice until or up to 1296, even if it has a label name like this. So every time when you have a label, just make sure that you prefix a dollar symbol to that. That is taken care by the macro processor, such that whenever there is a macro expansion, each expansion will be replaced with a unique name. Unique name is going to be $AA, $AB, $AC. For example, I have given name as here, instead of loop, I have given as a, let us say, jump. I have given this name. So what will happen now when I call this? When I call this, it will be $AA jump, $AB jump, $AC jump, $AD jump, like that. So whatever the name you write here, that name will be replaced with this prefix. What is the prefix now? AA, AB, AC, AD. So this is the concept of a generation of a unique labels. Why you require that? Simply because we have a label or a symbol in a macro definition, and if it is called only once, no issue at all. If the same macro is invoked more than once, which is a possibility, then we'll end up with the ambiguity. What is ambiguity? The same label name or symbol name will appear at multiple places, and the invocation like this or call like this will have an issue. So what is the issue? It will not be able to figure out which label I should be using at line number 1 or 10 or 15. So it will have a confusion. To avoid that confusion, ambiguity, we should generate a unique labels so that every expansion is unique, and hence every expansion containing a label is also unique. Thereby, we'll have a unique labels part of each of the macro invocation. If that is the case, ambiguity will be 0 and we'll have a smooth execution by this. And like this, how many we can have? We can call a macro up to 1296. How it is possible? Because it is alphanumeric character, 26 plus 10, 36. 36 into 36, 1296 combinations. This is how we can process a macro with a label inside it. Like that, you can have any number of labels within the macro. Every time, just make sure that you provide dollar as a prefix. Simply by providing dollar prefix, everything is taken care by the system or the macro processor. So this is for the today's class. So we have discussed about the algorithm what we have, and we also looked at the two concepts of a machine independent. One is that concatenation of macro parameters, and the other one is the generation of a unique labels. So if you have any